Okay, let's go over some of these homework problems together just to make sure that we are understanding everything, clearing up any misconceptions, so that we got a good footing on this. All right, so let's look at that first problem there. We got circle P, and then we've got a couple of tangents there, TH and TR, and they meet the radii. PH meets HT at point H, PR meets TR at point R, and we know that a radius meets a point of tangent C at a 90-degree angle. So that's going to be 90 degrees right there. That's going to be 90 degrees right there. All right. So if we're trying to figure out how many degrees n degrees is, I've got essentially here a quadrilateral, PHTR. And if you remember, the angles of a quadrilateral add up to 360 degrees. So really all I got to do to solve for angle n is add 90 plus 130 plus 90 again plus n and set it equal to 360. Okay? So when we do that, we add our like terms, we're going to get 310 plus n equals 360. So the measure of angle n is going to be 50 degrees. All right? So that one wasn't too bad. Okay, let's go ahead and go on to the next one over here, number 2. So here again, I've got circle P, and it's got a couple of tangents that meet at different sides of the circle. So I got ER and then EM. Now remember, one of the theorems that we talked about is that if you have an external point from a circle and you draw a tangent line on two different sides of the circle, then those two lines are going to be, or those two segments are going to be congruent when they hit the circle. So I know that this is going to be congruent to this. That makes this an isosceles triangle. And using the base angle theorem, if this is x degrees, then this over here is also going to be x degrees. Okay, guys? So if I want to figure out what x is, all I got to do is add all three of those together, set them equal to 180 because it's a triangle, and then I can solve for x. So I've got 48 plus x equals 180. And then, so 48 plus 2x is 180. We're going to subtract 48 from both sides. You get 2x equals 66, or sorry, 2x equals 132. Divide both sides by 2, and I'm going to get x is 66. Okay, guys? So it's going to be 66 degrees. Okay, let's go on down. Looks like we accidentally skipped over number 3, so let's look at number 4 here. Again, you've got a quadrilateral, and you've got radii that meet tangents. We know that they're going to meet at a 90-degree angle, and we know that the sum of all of the angles of a quadrilateral, which is essentially what this is, JWAP, if I add all four of those angles together, that's going to be 360 degrees. So basically, all you got to do is add all those together, set them equal to 360, and solve for z. I'm not going to spend a whole lot of time going over that one because it's pretty much like the one above it, just arranged a little differently. Okay? All right, number 5, you guys should recognize this as a 45-45-90 triangle. The reason I know that's true is because I know that PA is going to meet AT at a 90-degree angle. And so if this angle is 45, this angle would also have to be 45 because altogether they have to be 180. And if I add all that together, right, it's 180. And so that makes it a 45-45-90 triangle. And to go from the leg to the hypotenuse, you multiply the leg by the square root of 2. So if I'm going back the other way to get the leg, I need to divide the hypotenuse by the square root of 2. So that's going to make x equal to 15. Okay? So hopefully if we remembered our properties of special right triangles, we were able to get that one. Okay? Your next one, again, it's asking you to find the measure of angle CBD. All right, so again, you're going to have to realize that if these radii are drawn, AB and AD, they are going to be congruent, and that's going to make that middle triangle, BAD, a isosceles triangle. Okay, so if you take 180 minus 50, you get 130. If you divide that in half, then this angle right here is going to be 65 degrees. Okay, Now realize that this whole thing would be a 90-degree angle because it's where a radius meets a tangent line. So if you take 90 and subtract 65, you're going to end up with 25 degrees, and that's what CBD is going to be. It's going to be 25 degrees. Okay? Let's go down here to number 7. I've had several people ask me about this one. It's not as hard as it looks at first. Realize that CP is a radius, and we don't know what the measure is from here to here, but if this is x units long, then we can also say that this is x units long because it's a radius, and all radii of the same circle are going to be congruent. Now, this is going to form a right triangle because it's a radius drawn to a tangent line at the point of tangency. So that's going to make that a right triangle. Now, to solve for any missing side or any missing variable in a right triangle, we can always use Pythagorean theorem. A squared plus b squared equals c squared. So in this case, we can say x squared, which is this leg, plus 12 squared equals. Now we need an expression for our hypotenuse. It would be x plus 6 squared. Okay, guys, that's the total length of the hypotenuse. So now we need to do some simplification here. X squared plus 12 squared equals x squared plus 12x plus 36. If you went ahead and multiplied out that perfect square trinomial, that's what you would end up with. All right, guys, so now if we simplify, I know that I've got an x squared on both sides, so those are going to cancel out. I know that 12 squared is 144. So 144 equals 12x plus 36. Now all I got to do is subtract 36 from both sides. And I'm going to end up with 108 equals 12x. And then if you divide both sides by 12, you're going to get x equals 9. So there you go, guys. Not as hard as it looked at first because your quadratic canceled out. You didn't have to do any factoring there. So that made our lives a little bit easier. Okay, I'm going to do one more problem on the front side. Let's look at number 8. Okay, find the perimeter of the quadrilateral that is tangent to the given circle. All right, so if I look at that quadrilateral, I know all but this one little segment right here. Okay, otherwise I could just add everything up, but I'm missing that little part there. So basically what I'm going to have to do is I'm going to have to figure out what these missing segment lengths are using the fact that if a tangent line is drawn from an external point of a circle and another tangent line is drawn from that same point, then they're going to be congruent. So if this right here is 2.6, this right here would be 2.6, okay? If I take 4.3 minus 2.6, that's going to make this 1.7. And remember, if this is 1.7, then this is 1.7, all right? If this whole thing is 4.7, if I subtract 1.7 from 4.7, I'm going to get 3. And if this is 3, this is going to be 3. Okay? So the last thing I need to do to figure out what this missing length is here is subtract 3 from 4.8. That's going to make this 1.8. And if that's 1.8, this is 1.8. Okay, guys? So what you can do now is you can go ahead and add the 4.3 plus the 4.7 plus the 4.8, and then you would add the 1.8 and the 2.6, because that's this side over here. We've already accounted for those sides. So add that side plus that side plus that side plus those two together, and that's going to give you 18.2. Okay?